according to some stories, chemistry has been around for 5,000 years, but in the form of art. It's coming from alchemy, the art of alchemy. People were trying to get rich by converting copper to gold, converting lead to silver. So they were doing this secret. Santana? Our agreement is when I talk, you're listening. When I let you do problem solving, you're talking. Thank you. Guys, so people are doing experiments in their basement, going from one generation into another generation, trying to convert copper to gold for so many years. It's secret. Nobody is telling anybody it's the secret of making money. So at the time, they thought the universe is made out of 4 elements. What are those? Yes?
Earth, fire, wind, water.
Yes, thank you. Wait, says earth, fire, wind, and water, right? So they would get copper melted, that's putting fire inside, and see if it changes to gold. And then it didn't work. They say, we are going to heat it and then add some soil to it. Didn't work. They say, okay, we heat it, add soil, and blow air into it. And then we heat it, add water, soil, wind, increase it, decrease it. They say, if we can adjust the amount of the elements inside copper, we are going to get gold. It didn't work for so many thousands of years. Until 1600s. Chemistry becomes a science. What is the difference between science and art? In science, we run experiments, we make observation, that's what you do in the lab. We try to explain why certain observation was happened, you come up with hypothesis. You publish hypotheses with other scientists. Everybody criticizes you, you have to prove that you are wrong. They do experimentation, make sure your result is reproducible. Then you come up with a theory. So, 150 years after chemistry is becoming science, scientists are doing experiments, they're publishing papers all around the world. And this guy, Dalton, he's a teacher, English science teacher. He says, I'm going to read all the theories, and I want to understand, what do we know about the nature of matter? What is matter made of? So he reads all the papers, and he come up with a theory which is still valid today. We are using Dalton theory today. And he says, number one, based on everything I know, everything I read, everything we know at this point in the history, all elements are composed of small particles. They are called atoms. And the reason that different elements behave differently, the reason that copper is copper and gold is gold, is because they have different atoms. So atoms of same elements, they are identical, they have same behavior, and atoms of different elements are different. That's number one. Number two, he says there are compounds which are made out of elements. And he says compounds have at least 2 different atoms bonded together. 2 or more atoms, when they bond together, then you make compounds. And he says the ratio between number of combining atoms in a compound remains the same. What do I mean by that? Guys, can I say hydrogen and hydrogen, compound or element? Element is made out of same type of atom, right? Yes. And oxygen, compound or element? Element Y is made out of same types of atoms. Yes? And they react together. They make water.
Compound.
Yes. Thank you. Krista, good job.
It wasn't me.
Oh, no,
No,
honestly.
I'm kidding.
Aha, I know your voice. Okay. Do I need two of these? To balance it, yes? Compound or element? It's a compound, why? It's made out of two different atoms, right? He says, the ratio between number of atoms in a compound remains the same. Can I say the ratio here is 2 to 1? The ratio of hydrogen to oxygen is 2 to 1, yes? If it is H3O, is it water? No. Doesn't matter where you go on Earth. Water, the formula of water is H2O. Doesn't matter where you go in universe. Where you find water is H2O. The ratio between number of combining atoms inside the compound remains the same. If it is H2O2, it's not water, it's not going to quench your thirst, it's going to blonde your hair. Because hydrogen peroxide, totally different. You change this ratio, you don't have same property. Okay. And then he said, what are chemical reactions? What are chemical reactions? He says, chemical reactions are nothing but bond breaking and bond forming. So we do that all the time, don't we? You see somebody, he is the right person, or she is the right person, you marry, bond of marriage. Chemical bonding, similar to bond of marriage for us. It's bond between atoms, they stick together. They stick together, they stick together. What if they are not happy? What if they find another, what do you do when you are not happy from your marriage? You divorce, you break a bond. You find somebody better, you make a new bond. That's what atoms do. They break a bond, they make new bond to be happier. What's happiness for atoms and compounds? Having less energy, becoming more stable, losing energy and gaining stability. That's why chemical bonding is happening. So it says, chemical reactions involve rearrangement of atoms. And in this process, atoms are not created, and atoms are not destroyed. How many hydrogens on the left?
2.
How many hydrogens on the left?
3.
How many hydrogens on the left?
3.
How many here?
2.
2 times 2?
4.
How many hydrogens here? 2 times 2? 4. How many oxygens on the left?
1.
How many oxygen atoms?
2.
How many oxygen atoms? 2. Atoms are not created or destroyed in a chemical reaction. They simply rearrange. They break a bond and they make a bond. That's what chemistry is all about. So Dalton says, everything in our universe is made of atom. Immediately scientists, once they accept the concept, they go to the lab. Let's find out what is atom made of. What's inside atom of copper, which makes copper different from atoms of gold? Why gold behave differently? So this is the experiment. Let me turn off the light. I am hoping that you can see. Do you see a blue light here? This was called glow tube or cathode ray. Physicists knew about this, but they couldn't explain it for so many years. They had seen this phenomenon. If you take a glass tubing, if you evacuate it, connect the two ends to negative charge and positive charge, they would see this glow. This glow would only be seen if I have a phosphorescence covered on the plate. Do you see that? So, one of the scientists did this experiment. He took a magnet, brought the magnet here. Do you see what is happening? Yes? Oh, whatever is inside this cathode ray is interacting with magnetic field. What is that telling you? If this is being bent by a magnet, what is telling you about this particle?
It has an electric charge.
So, let me give you another example, another demo. Maybe you can come up with an idea why this globe is being bent by a magnetic field. So what I have here, light change? Oh, yes.
Could you, what is making the glow again?
I'm going to explain it.
Oh, okay.
I want you to first think and come up with a solution. So I'm going to give you another explanation which may help you understand this. This is a 9-volt battery. I am connecting the two ends, negative and positive, of this 9-volt battery. And then, let me see if I can find a paper here. Guys, the nail that I have here, I have a nail, a big nail. Around it, I have got a coil of copper wire. And then I'm going to pass electricity through this coil. And I want you to make an observation. Is this magnetized?
Yes.
So this nail is magnetized, right? I removed the electricity, it fell off, right?
Yes.
So physicists knew that. What is the experiment telling you? It's telling you that if you have electrons moving inside, if electrons have a circular motion, they produce magnetic field. Yes? Moving charged particles produces magnetic field. And the fact that this blue glow is interacting with the magnetic field, two magnets repel each other or attract each other, right? It means this must have magnetic field. If this has magnetic field, it means it must be charged particle. And they say, inside this metal where I have connected the negatively charged potential, the atoms are ejecting a particle which has charge. Now what is the charge of this particle? I'll be like, yes, I can definitely answer that question as soon as I find out what. Yes, let's see, is it negative or not? So I'm going, this is negative terminal, and look, I'm going to bring it to this end. Is it repelling it or not?
Yes.
What is repelled by negative?
Apparently your projector.
My projector is dying. Can I say, if this is negative, and the blue ray is being repelled by negative, what is that telling you about the charge of the particles here?
Positive.
Positive and negative attract each other.
They're negative.
Only light charges repel, right? This is negative. So what is the charge in the blue ray?
Positive.
If it is positive, it will be attracted. It will come up. Is it being repelled? One more time.
Yes.
It's being repelled, right? If it is repelled, it must be negative, right? Okay. Very high voltage, by the way. So J.J. Thomson says, atom must be composed of negatively charged particles that we are going to, we name it electron nowadays, right? That's the first experiment. Which tells you what matter is made of. So guys, does the amount of repulsion depends on the charge of the particle, charge of the electron. If there is more charge in an electron, it's going to be more repelled by negative charge. If it is less charge, it's going to be less repelled. So if I measure amount of repulsion, And I know the negative charge, I can calculate. There was a formula by physicists. They can measure the charge. But also mass is important. If I take this chocolate and throw it at this wall, well, I'm going to throw this chocolate at this wall. It went up there, right? What if I take a bowling ball and throw it to the wall? Is it going to hit the same height?
No.
It's heavier. It's going to hit on the, closer to the floor, right? I can measure this distance from the floor. That is also showing it's related to the mass. So amount of deflection is related to the mass and charge of electron. So by doing calculations that you are not supposed to know, he measures the ratio of charge of electron over mass of electron. So we know, please. Okay. Thank you. So he says, I know now what is the ratio of charge to mass, but still they don't know what is the charge. If I say I am 3 times older than Maggie, would you know how old Maggie is? No. Would you know how old I am? No. You need one more piece of information. What is the other piece of information? Maggie is 20, I'm 60, right? Or I'm 100 years old, Maggie is 33 years old.